right. Can you explain why some people experience brain fog and what may be happening neurologically when it occurs? So how many people here had COVID? How many people experienced brain fog? Yeah. So this was a prominent feature, and this sort of came into, I think, a lot of popular parlance during COVID because so many people were experiencing this phenomenon known as brain fog. And I actually got quite interested in it. I think at one point we were going to do an episode on it.
I still want to do an episode on brain fog.
Because there's a lot.
I keep forgetting to do it.
Anyway, so what it boils down to is it relates to, not surprisingly for the neuro folks in the room, inflammation in the brain. So highly do not recommend Googling your symptoms when you have COVID and brain fog because you're suddenly aware of all the things that are happening in your brain. So COVID was marked by, it was an increase in the cytokines, which are the immune system's major signaling molecule. They're like neurotransmitters, but for the immune system. And you can have these pro-inflammatory or anti-inflammatory cytokines. And some of the pro-inflammatory ones are things like TNF-alpha, interleukin-6, interleukin-1. And it looks like brain fog is marked by this increase in these inflammatory cytokines in the brain. What that actually translates to is a little bit unknown, but they seem to be especially prominent in areas of the brain that we know are involved in cognitive functions, such as the hippocampus and the prefrontal cortex.
We show the hippocampus book every time we mention.
Yeah, it's on page 1222. The other thing is that, as I mentioned earlier, the brain is a metabolically hungry organ. It uses a lot of energy. It requires it. And everybody remember learning in grade 10 biology or whatever it is, the mitochondria, the powerhouse of the cell, right? It's like a cigar. If the mitochondria aren't functioning well, and that could be due to stress, illness, poor nutrition, as well as inflammation, you get this compromised production of ATP, or adenosine triphosphate, which, again, if you learned in grade 9 or 10 chemistry, biology, that's the main energy output of the cell. So there seems to be this link between, again, illness, inflammation, reduction in mitochondrial functioning, decreased ATP, and this means that you have decreased energy and resources available for cognitive tasks. So this is also related, we were thinking about doing an episode not on sleepiness and tired,
mental fatigue.
Mental fatigue.
Yeah, we'll do it.
Very, very similar. So anyway, so those are sort of the highlights of what we know about brain fog and its impacts on the inflammation of the brain. So apparently also dehydration can relate. So if you're dehydrated quite a bit, have a sip of water. This can also influence brain fog and hormones. So very common in perimenopause and menopause as well.
Brain fog? Mm-hmm. All right, next question. What's the connection between cognitive load and memory retention? How do we optimize learning? So cognitive load is when your mind is, you have to remember so much and process so much that you're either overwhelmed or you can't take in any more. In psychology experiments, cognitive load is usually done with very unpleasant experiences like count backwards by 7 from the number 3,000. And you're trying to do this while you're, trying to judge whether faces are male or female or something like that. And this, I was talking to a friend and she helped me realize that all of these cognitive load tests are unpleasant. And that's a confound. Anyway.
Oh, because it's something that's unpleasant.
Yeah, maybe what we think is cognitive load might be the unpleasantness. So I think somebody should investigate that. That's a little sidebar. Anyways, the question, cognitive load, your mind is full, what you're doing. And what's its relationship to memory retention? And how do we optimize learning? So studies basically show that cognitive load is not good for learning. When people are under cognitive load, the memory retention is lessened. Now, sometimes you need to have cognitive load to learn something. Some things are just complicated. And I don't know if you've ever encountered this, but I've tried to learn things and I just feel like I just cannot get it. And often it's because it requires too much for my working memory to handle. If I don't get it all in at once, it doesn't click and I lose sight of things. And maybe if I spent many years building up more and more abstract representations, I could fit what I needed to, but it just felt beyond me. So to learn some things, you need cognitive load, but the cognitive load itself isn't helping. Okay? So basically, if you can try to learn something where the cognitive load is less, it's going to be easier to learn. Some ways to do that, sometimes visualizations of things rather than, just a pure text can sometimes get the gist of something in sort of a smaller package or a more digestible package. The other part of the question was, how do we optimize learning? We talked a little bit about that in a previous question. But when you're trying to memorize something or get a skill, again, practicing at that task, either practicing retrieving those memories or practicing doing something. The repetition, but also repetition with not a whole lot of time between them. So, every day or not a whole lot at once, but, things spaced out are really good for that. Also, if you can get feedback, it's really handy, right? So certain things, it's harder to get feedback. So writing novels. It takes so long to write a novel that, your feedback on the novel is you have to wait years to get it, as opposed to one time I learned how to walk on stilts. Talk about fast feedback. You're going to fall. You feel yourself falling, and somebody has to catch you until you get the hang of it. If you can get in a situation where you can get feedback, so the repetition, but repetition with feedback, it makes it even better and faster.
All right, the next question is, what is the most surprising thing you've discovered in your own research about the brain that changed the way you think about how we function? And so one thing I've also studied for a long time is the impact of trauma on the brain. And so in that work, I've come to understand the importance of our early life environment. So the experiences that we have as children, as youth, can be really impacted by things like stress, trauma, even things like nutrition. And this can shape the way that our brains develop, as well as how we respond to the world as adults. So I used to, before I entered neuroscience, thought the brain is a pretty static thing. Now, of course, I've come to appreciate how dynamic and changeable it is, and sensitive, frankly, right? There are certainly developmental windows where the impact of the environment on the developing brain can have much more significant consequence. And one of the things that I've studied all throughout my doctoral degree, as well as my postdocs, is how early life trauma, and in particular chronic stress, can change the wiring of the HPA axis, that critical brain system that's involved in how we respond to stress. And in particular, that people who have these early life traumatic events have a heightened stress response. So in the face of a mild to moderate stressors, they actually have much, much greater cortisol release, as well as ACTH, the hormone that is the signaler to cortisol, have a greater court response, or in fact blunted. So they, can go two ways. They have a heightened stress response, or over time they actually have this blunted court response. It's almost like the body is kind of given up, right? And this, of course, is what is one of the most potent mechanisms, that is the vulnerability to later life psychiatric disorders, including things like substance use disorders. And the wild thing is that these changes happen without us even realizing it. And this is what also, I think, relates to a lot of stigmatized beliefs about psychiatric illness, and in particular substance use disorders, which I'm very, of course, passionate about, is that these changes they may lay dormant for years until we are adults and we start making decisions, or we start using substances, or we experience stress during university, and it can unmask some of these biologic vulnerabilities, and can even be passed down to generations via epigenetics, which is a very, I didn't realize that until much later in my studies, that epigenetic changes are heritable, which is wild, and it goes against what we learned in, again, grade 9 biology, Darwinian Punnett squares, right? X, big B, little b. That's how things are inherited. And in fact, now we know that we, through generational trauma, right, that we can inherit the worries and troubles of our grandparents, and in fact generations above them, right? So this has been studied in things like intergenerational trauma among residential schools, the Holocaust survivors. Now we have, across the globe, even more geopolitical strife. We can only begin to imagine people living in Gaza and their experiences, and the generations of children that have been survivors of the war. So I guess this has really changed the way I think about human behavior, and also given me a lot of compassion. I always try to teach with compassion. I try to teach with the notion that many of us have experienced these horrific things, that we are not to be forgiven for the decisions that we make, because some people, this results in criminality. But, I believe love the sinner, hate the sin, right? That it is really people have experienced atrocities that have changed who they are in very profound ways, and that this is why I do the work that I do, to understand more about what I would characterize as stress dysregulation disorders, and how knowledge of this can reduce the stigma for people who are facing substance use disorders as well as severe psychiatric illness. So it's made me more empathic and more compassionate, and that's definitely one of the things that I really strive to have in my classrooms, is that people walk away with a greater appreciation and empathy for people in these positions.
Next question. If you could give one piece of advice to people looking to improve their cognitive health and brain function, what would it be? My number one is get enough sleep. Sleep is way more important than almost everyone realizes. Lots of people don't get enough sleep. They sabotage themselves by doing stuff at night, like people on their phones or whatever.
No, I sleep 8
Kim
hours
wouldn't do it.
every night.
Do you?
Oh yeah, religious. 8 hours, 8.5, sometimes 9.
If you're feeling wild, 9 hours sleep. But yeah, getting enough sleep is like the easiest, most pleasant way to improve, like keeping your weight under control, being mentally acute, fighting depression and anxiety, and general health. That is the number one thing I would say. I think a close second is socializing, making sure that you have a rich social life. I think that a lot of young people are what we are calling sort of COVID cohorts, where they had a little bit of a stunted social experience during COVID, which are some very formative years, and are still suffering from it. And I get it, like especially in the modern world, it's a real pain sometimes to like arrange things with people. People are busy and it takes forever and they cancel, and it's just easier to watch TV or do something solitary, but it's worth it. It's worth it for your health, your mental health, and your longevity. So if you look at all of the ways you can even try to live a longer life, socializing is on top, more than quitting smoking, more than exercise, more than a better diet. But the number one thing I think most people are missing is getting enough sleep. So really prioritizing, most people don't have a problem getting up too early. They have a problem going to bed early enough. So if you can try to engineer your life so that you're getting enough sleep, you'll probably reap some benefits. This is mine too.
I think the last ones are you. Yeah, this is all you, Jim.
Okay.
I can sit back.
Kim's going on break. You want to scroll on your phone while I answer these? All right. Are there any surprising ways in which our brains adapt or compensate for cognitive decline, especially as we age? Okay, cognitive decline. It's real.
Are you speaking from experience?
Nice. Get on your phone, will you? Bugging me.
I think Jim's only
hippocampus.
You're
Just hold the hippocampus book. So intelligence is generally measured in two kinds of ways, fluid and crystallized. So fluid intelligence is sort of quick thinking, analysis of new things, abstract reasoning, and that kind of thing. And that tends to increase gradually, or actually pretty sharply, until around age 30. And then it starts to decline for the rest of your life. And there's not much you can do about it.
Oh, God.
You knew this, right?
No.
Yeah. So yeah, that's pretty true. I mean, some people are quite smart at 30, but however smart you are at 30, it's going to start declining afterward. However, crystallized intelligence is how you are able to recruit what you know to be effective in the world. And crystallized intelligence continues to increase until you start to experience serious old age related declines in your late 70s, early 80s. So the crystallized intelligence, it asymptotes, so it increases more slowly, but generally the more you learn, the more effective you are in the world. So, and you might talk to an old professor, right? They might have a lower fluid intelligence than you or whatever, but they might appear to be incredibly smart, particularly in their own domain, because they have so much experience, and they can draw upon patterns that they've learned and apply it really seemingly quickly. It seems like they're thinking really, really fast. They're not thinking fast. They just have memories and routines and strategies that they've honed over years. But you put them in a brand new domain, they have much more trouble with it, right? So this is why you see, particularly as they age, people tend to have trouble with newer technologies, right? So somebody could be really wise at how to run their business or do this or that, but they can't hook up the Nintendo Switch for their kid or something like that. One consequence of this is, so anyway, the question is how do we adapt or compensate for cognitive decline? And one of the ways is just a better recruitment of what is known. And what's interesting about this is that the world used to change very, very little, over the course of one's lifetime. So until probably the 20th century, I would say, the world you were born into looked a lot like the world you died in. And so old people were valuable because they've had a lot of experience in the world that you are living in. But if you look particularly in the 20th century, we had rapid change, introduction of cars and televisions and refrigerators, and somebody could be born on a dirt road with no running water and die in a world with computers. So the faster the world is changing, the less valuable that crystallized knowledge is, because the world has sort of moved on from the memories that you're relying on, right? And I think this is part of the reason that in technological cultures there's less of a respect for the elderly than there maybe was in the past, because their crystallized knowledge isn't always relevant, right?
Well, that's depressing.
So we got one more. Do you think there are parts of the brain that might be unused or underutilized? You could help me with this one. Do you think there are parts of the brain that might be unused or underutilized, and could we potentially unlock hidden brain functions in the future? The answer is no.
He's definitive.
Absolutely not. And I'm pretty sure about that. I have high confidence with this, and I'll tell you why. One is that evolution is pretty ruthless about getting rid of things we don't use. So if there is a part of your brain that is not pulling its weight, I don't say if there's a part of the human brain that is not pulling its weight in terms of making more kids, then people with that part of their brain smaller are going to reproduce those that have a bigger version of that, because it's less metabolically expensive. As Kim's mentioned, the brain is incredibly a hungry organ, eating 20% of the energy, and it's 2% of the mass or something like that. Right. It's really hungry, and all the neurons are firing all the time at some rate. So evolution's not going to mess around with that. It's not going to have some hungry piece that's there to unlock some hidden potential using up energy that isn't getting used. No, it's out the window. The only time we have vestigial organs, I don't even know if there are any left, but they have to have a very, very low nutritive cost to survive, and they gradually decline. The other thing I want to say is that your brain is in it can't get any bigger, right? If human brains got any bigger, women like wouldn't be able to walk. Like already childbirth is extraordinarily dangerous for humans compared to many, many other animals. And part of that is because a big, smart brain has been so advantageous that it's been getting bigger and bigger, and the childbirth has been getting more and more dangerous, and there are all these workarounds. You know, babies like have their skull in 3 pieces. You're not supposed to touch them in the head, in the center, and women's pelvises like come apart for childbirth, and it's like, it's crazy, all these like workarounds to try to get this big head through. So is evolution going to be like, yeah, let's have some unused things in there and risk everybody's life? No.
That was quite a rant.
Well, you know, I know a lot about childbirth. I was there. I was born once. You want to add anything?
No, that was good. No. I think are we okay to take a few questions from the audience, if that's okay? So the question is, so we know when somebody is needing to be prescribed antidepressants, as an example, for treatment of depression, it's very rare that you're going to be like, all right, here's your prescription for escitalopram, 200 milligrams, and then you're like, great, I feel awesome. Very rare. More often than not, you play around with the dose doesn't work, you add on something else, you try a different one. So the question is apparently, is there a way to genetically test how you might respond to certain meds? And not to my knowledge is there a kit, but certainly there is the Can Bind group here in Canada that is endeavoring to create massive data sets for exactly that purpose, where they're trying to get people coming in and doing EEG, baseline genetic tests, saliva markers, you name it, and to see who are the best responders to escitalopram, let's say, who are the best responders to Prozac. I'm mixing up generic and brand names here. And with exactly that in mind, that's the goal, is precision medicine. So we can get you in, you do a pinprick test or a saliva thing. We see, oh, here's your genetic expression. Oh, better yet, here's your epigenetic expression. And we think that you're going to be a rapid responder to this treatment. But I don't think we're there yet in terms of offering that as an at-home kit or solution. Certainly, I can imagine there's some venture capitalists out in California salivating at the possibility of this. I mean, it would revolutionize medicine, let's be honest. And I think that is a goal that we should be aspiring to in terms of really nailing down treatments, because there's a lot of people that suffer and it takes a long time. So
like personalized medicine is like a holy grail that people have been talking about, not just for psychoactive medication, but all kinds of treatments. Yeah. So we already know, like, there's gendered impacts, right? That and I ran some of these studies as preclinical research in my postdoc, and we saw very clear differences between male and female rats in their response to certain antidepressants, and yet that wasn't even out there in the clinical literature, right? People were being prescribed these things willy-nilly. That was like in the mid-2000s, so it's not that long ago. Anyway, yes, good question. So the question is from Christina, wondering about how we have come to embrace a very different view of neurodiversity. How has that happened? Neurodivergence is being recognized as something that is wonderful as opposed to something that needs to be treated. And then, of course, like, where do we need to still grow? Where do we still need to do research and understand more about neurodivergence? And I would say that a lot of the changes that have come, because for sure, get back to when I was a baby grad student, autism was seen as something that we needed to treat and fix, right? And now there's a real divide in the community, because I can also appreciate that sometimes if somebody has certain traits or skills, like, for example, if you had a nonverbal child, I'm sure you would want some intervention to help support how to communicate with that child. So that's an example of how I think there's still a space for that. But really, the movement has come from the community, and that's I think a real wonderful thing that I've seen over the last decade or two is listening to people with lived experience, right? Like, for a long time, we've had this elitism in science where it's like, I have the PhD, I know best, I'm highly educated, I study this, I'm going to look at you under a microscope, and I'm going to tell you what I think you need, right?
I think we are seeing this lovely empowering of people with lived experience that are informing science and better actually co-leading the science. And so that's where I've seen the movement really grow, and it's been the community and working in allyship with people from those communities. And I would say we still have a long way to go, particularly as it comes to recognizing neurodivergency is different among genders, it's different even among racialized communities, culture, right? So there's still a lot of space for us to really listen and learn and unlearn and relearn. And I think that's what I'm eager to see. Unfortunately, I think we are living in very challenging times. We are going to be facing a lot of headwinds as it relates to EDI in general in this era. So I think all the more time for us to work in allyship and to be powerful advocates for people from those communities, because
Yeah.
yeah,
I want to add that the neurodiversity movement is about reducing stigma and helping those people flourish. And it is and that's great. It butts heads against a different, also well-meaning notion that people need help for medical problems, right? Mm-hmm. And I think the similar problems are plaguing transgender and gender dysphoria stuff, because on the one hand, they want insurance to pay for it, but insurance isn't going to pay for something that's not a problem. So on the one hand, we don't want to stigmatize somebody, but on the other hand, if they need treatment, we need to get it for them. And it's sort of like two different worlds. Like in some contexts, you want to say that it's a disease, and in other contexts, you want to say that it's just a part of normal human functioning. And because of the way our society is set up with the medical system and insurance and everything, I think I agree that there are strides to be made, but I think there is an inherent conflict with the way our society is set up in dealing with these kind of stuff.
Yeah, good point.
So like 7 minutes left. Do you want to take one more? Or do you want?
Yeah.
Okay.
Yeah.
The question involves the apparent correlation between neurodiversity and STEM fields, and whether people being attracted to STEM fields because of more cut and dried, black and white thinking is losing an opportunity to improve thinking about gray areas and social issues and this kind of thing. I will say that we don't want to associate neurodiversity necessarily with autism spectrum. Neurodiversity is supposed to be all the kinds of stuff. And I would say that if you look at what some consider the opposite of autism, which is psychosis, you see very few people in STEM. So it's not like all neurodiverse people are drawn to STEM. It's a particular flavor of neurodiversity. And this is something that is, you don't agree?
What did you just say?
The psychosis is the opposite of autism? Yeah, that's Simon Baron-Cohen's theory.
Really?
Yeah.
Grounded in reality, outside of reality, I think is the concept.
Anyway,
Okay.
it's controversial,
Yeah.
but it's out there, right? But even if that's not a spectrum, even that those aren't 2 points poles on a spectrum, I think the point stands that neurodiversity is more than autism spectrum. But I will say that a lot of things that people with autism symptoms share a lot with kind of what we would consider a nerd stereotype, which is often associated, as everyone knows, with social awkwardness and interests in very systematic kinds of fields, chess, math, and then STEM and engineering and this kind of thing. And so they get because they're sort of confused by complex social things, they don't really want to read Tolstoy. They'd rather look at chess, which is very discrete, or something like that. But your question's the second part of your question is an interesting one regarding, should they be encouraged to do the thing that they're not good at? I think that's a great point, and the answer is probably yes. There's a real tendency for people to move toward the things that they're naturally good at. And although I think that is sometimes good, it does need to be counterbalanced. And so the reason that universities in this part of the world often require you to have electives or classes that are outside of your discipline is because we think that a well-educated person needs to build on their weaknesses and not just their strengths, and they need to have broad interests. There's an old saying that the expert improves on what they're good at and the master improves on what they're bad at. And so I think there's a real tendency to do what you're good at and what you like. But yes, if you're someone who has particular deficiencies, and it doesn't need to be clinically diagnosed, but if you've got particular deficiencies with certain kinds of thinking that's actually important in this world, like thinking about money, like everyone's got to deal with their finances, and if you're really bad at that, you say, oh, I hate money, I hate numbers, so I'm going to ignore that. You are probably doing yourself a disservice.
And I would say that's why it's really important to have diversity in all fields. Right? That we need lots of different perspectives to inform lots of different things. Like, this is why it really worries me in AI. Like, do we have people who are not these kinds of thinkers out there making decisions about how AI is used, right? And how are we having moralists, philosophers, sociologists, ethnographers? Like, are we actually looking at this from lots of different perspectives and lenses? Or is the world going to be taken over by people who are making these decisions that look at the world through this very black and white thinking? So, this is why I'm a big fan of diversity, and that's why we need neurodiversity in lots of different spaces, not just STEM, and why we need perspectives that are valuable everywhere. So, yeah.
Okay. Well, thank you everybody for
thank you.
Good questions.
And
thanks for coming.
A reminder: if you have other questions, we do have the opportunity. You can email Minding the Brain podcast Gmail, I think it is, or something like that. Anyway, you can email us, and we'll be doing these Q&As pretty regularly, and we'll answer your questions. So thank you so much.